attached to each key, so the keyboards are organ keyboards.
And there's plenty of downtimers.
There's plenty of organs, so that's not a problem. So, but I just don't think we've gotten weird enough yet. Okay?
Rick,
Yeah.
you may, in the terms of graphics display, you may recall the water-based display that I sent you a photo
that. Yeah,
of from
I know.
the museum.
Yeah, we'll talk
Bubbles.
about. I'm not going to talk about that here, and I'll tell you why later.
Okay.
Personally, this is Terminal 5 at Heathrow.
You're to have a water leak problem.
It's intermittent.
It's intermittent. It's a grid of fountains. Do you see that?
It's fluid.
It's fluid. It's a grid of fountains. Imagine what that looks like standing from the balcony above, and I had another video with that, but I couldn't get it into my PowerPoint. But do you see I've got a grid of fountains, each one of which are individually controllable, right? So we have a different name for it. Calling it the Heathrow fountain display is just stupid, okay? But imagine, nevertheless, a pan of water, which could be any size because I can control whatever amount of flow I want with the fluidic amplifier. So whatever size you want, from a pan of water to a swimming pool with little output tubes just under the surface so that they can pop up a little jet, right? And I can control those jets individually in an XY grid, right? And so I've got a two-dimensional, or depending on, and this is where it gets fuzzy, can I modulate the velocity and control the display in 3 dimensions? Maybe. I don't know. But we call it the Bellagio fountain display. Okay? Because if you've ever seen the dancing waters of the fountains at the Bellagio Hotel, it's an amazing water show. So we call this the Bellagio fountain display because it's a lot more fun than the Heathrow. fountain.
Now, Rick, there's actually something that gives it that name another boost. During the period 1600 to 1620, roughly, there was a tremendous amount of work done by Italian designers for gardens and theaters, and the borders there were being blurred with very fancy controlled water displays. So that I can imagine those people getting attracted or recruited into this display technology.
Me too.
Rick,
Yeah.
are you looking at the water, or does it actually do something?
No,
like
no,
if
you're
the
looking
pressure
at the
is
water.
on, it flips
You're
something into
looking
place.
at the water.
Okay.
Flip-flop type displays are very doable, and the character-oriented displays would be flip-flop type displays.
Yeah, which place essentially you're dealing with a mosaic.
Exactly. It's a mosaic. But I wanted something more dramatic, Chuck. I'm
I just
sorry.
thought mosaic would require
Mosaic?
almost no background.
Yeah, mosaic
Okay.
works great. Okay.
Rick, you have a question over here.
Yeah. Sorry.
Going back to the RAM,
Yeah.
are you still looking at that as being a dynamic RAM, or do you have something in place that's going to make it static?
I've got bistable flip-flops, so that part's dynamic.
Right. So
Okay.
if something were to happen and your flow is cut off, then all your memory is dumped.
Yeah, just like if your computer shuts off in the memory.
Right.
Yeah.
Okay.
Now, I still have to do an initial program load, right? I have to IPL this machine, right? So, but again, all I'm controlling to do the IPL, remember I've got an organ keyboard as my keyboard. All I have to do the IPL is control a parallel set of fluid flows, right?
Right.
Are these like stops on the
Well, no,
organ?
it's better than that.
You might even be able to
Not-
set that up with like a punch card type thing.
You could use Jacquard style punch cards, but really I think the correct answer is a piano roll.
Yes, absolutely.
What?
A piano roll.
Like on a player piano.
Piano.
Yeah, that's your floppy disk.
Yeah, that's,
Yeah.
well,
It's very floppy.
yeah, it's not writable. It's readable.
Especially if you get it wet.
So that's your
To
idea.
control the
Okay.
torpedo,
Yeah.
one design.
And one thing that
I haven't developed a ROM, by the way. I keep thinking about it. ROMs in this technology turn out to be hard. Yeah.
Every time I mention this on the boards, it usually sets off a huge flame war that runs away from my initial comment. But what this would do is change the terminology of the computer deep speak. But it would also, if you think about, I like the history of science, if you think about what caused one computer system to take precedence over another, one display type, or one, why did COBOL die and Fortran linger for as long as it did? This, whatever you're going to start doing is going to change subtly, it's going to shift what people see as normal. The same way that when the Stanley steamer failed, we went to internal combustion on a steam-powered car. And there might have been other reasons too, like Hugo's blowing up on the interstate randomly.
I hate when that happens.
But that's an interesting part of this, I think, in the story, is figuring out what terminology, what would a downtimer call this? He might not call it the Bellagio because he's never been to Vegas.
Right.
And can't.
Right.
So that's another interesting part that I think
Right, which is why Ivor said Bellagio might come from the.
They would believe an
Italian
Italian
But
designer.
You're right. The terminology gets real interesting. You're absolutely correct.
We're only, in the real timeline, in the original timeline, we're only 20 years from the dancing gardens in Versailles.
Yes.
The dancing fountains in Versailles.
Right.
Which means that all the people that built those things are alive and working.
Plus, we have Althanius Kirker in Grantville, who is one of the top hydraulics, automation, fountain design guys in the world. Okay, in Grantville. So this all, huh?
You should do research.
That Althanius Kirker's.
Read Grantville Gazette.
Okay, Althanius Kirker is in Grantville and has been for years.
I know, but I didn't know that he.
Oh, you didn't know who he was?
I know who he is, but I mean.
Okay, Father Althanius Kirker is one of the top. He invented. He made, among other things, he made an incredibly elaborate water clock that is based on some of the.
Engineering Galileo.
Huh?
Yeah.
He persecuted Galileo.
Yes.
You also had someone do the design for the Prince Archbishop of Salzburg.
Yeah, the Salzburg
water
water
garden
garden.
stuff.
So everybody
Not just the water
understands.
garden, but he had things where the guests would sit down at the table outdoors, and all the seats had
Water jet.
water
Water
jets
jets, yes.
equipped, which he could control to goose a
Right.
particular.
There's your mosaic display of people.
I'm going to run back for just a minute
We need to
because
take
I've
a
got this
break.
other side of this slide that I didn't discuss, okay? These were clingy, right? I can flip it and it stays there. I can flip it and it stays there. With a slight difference in design, notice how I've got a chamber here now, okay? With a slight difference in design, I can modulate to the extent to which that stream goes out one side or the other. So by varying the pressure here, I can get a little bit out this side or a lot out this side, and of course the opposite, right?
So you've got an
So
analog.
if this
You have an
is a
analog
very high-powered power stream, and that is a very low-powered signal, I have an amplifier. At the World's Fair in 1930 in New York, the big PA amplifiers there were Coanda effect fluidic amplifiers.
Really?
Really, because the tubes couldn't handle the finals power. And so they built big air horns powered by fluidic amplifiers for the PA system. And so they had a microphone that the guy talked into, and they had some electronics, but literally there have been built systems where you all have seen the classic Victrola crank-up phonograph
Right.
with the big horn,
Bo-
right? Okay, rip the big horn off. Underneath the horn, there's a diaphragm that attaches to the needle that goes, and the diaphragm moves up and down, right?
Makes
and that's what
noise.
makes the sound as it moves up and down on the record. That makes sense? Okay, so what happens if I encapsulate that diaphragm in a little dome and take a tube off of it and put the tube into here?
You're feeding the sound into your
Feeding the
Kawanda.
sound into my amplifier, and what comes out this side is an airstream that's many times
Louder.
louder than the signal that went in.
Okay, Rick.
Feed that into a horn, and you've got the room.
Better than a horn. You feed it into a grate on a flame jet. You put the flame jet 60 feet high and you vibrate.
Yeah, there's always that.
Remember, that isn't necessarily water. Hydraulic
Right, this is
applies
air.
to
It can be,
any
yeah.
fluid,
Right.
air, gas.
Right.
Alcohol,
And it
propane.
turns out that there are a lot of ways to build fluidic amplifiers. So you've got the little A-B triangle one there. You've got this one, which is called an aerodynamic amplifier. This one, and you've got this one, which is one of my favorites, that's a vortex amplifier.
And it sticks to the wall all the way around.
There's, the input is here and the output is in the center at 90 degrees. So the air spirals in. And the depth of the spiral is controlled by your control input. All of these are different. All of them work. There are other designs that work. This is really cool tech. It's just we don't use it because electronics works so well.
And it was already.
doesn't have a place in our timeline. It had a huge place downtime. Does that make sense?
And you can build every single one of those the same way that Rick talked about before, by pressing the circuit. It's like cuneiform on steroids.
Is that what is it?
Cuneiform, the clay
Sans-
tablet. Clay
Sanskrit.
tablet, Babylon,
Okay. So
Now we know
moving-
why they were doing that.
They do.
moving on because if I don't move on, I don't get through everything. and
Do
I
we?
throw this
We've
over.
done an hour. Do we need like a little break?
I was about to. I'm going to take a little break in 1 second because yeah, we have. I have back-to-back sessions here, and it's now 11, and some of you may have had things to go to at 11, unless you're having too much fun. So we'll talk about this after a short break, but I want to get water. Remember, we don't have electronics. The whole electronics thing, I told you about that, right? In our story, Gustav Adolphus, the king of Sweden, becomes
The emperor.
Emperor Gustav Adolphus of most of Europe, Germany, Denmark. It's really cool. The Uptimers have a radio station in Granville. They build one out of a ham radio operator's home equipment. They make a radio station. They call it the Voice of America.
Because what else?
Because what else would you call it, right? Okay. And the VOA goes on the air within days or a couple of weeks of the event and gets improved and ramped up over the course of the next couple of years until we eventually build the Great Stone Radio Tower, which is a 400-foot tall radio antenna made like a cathedral tower with a wooden top
And really nice
copper
arches.
and radiating elements running up the corners, and it's fun. But we're not going to talk about that right now. But Gustav wants a radio station. He wants the voice of Luther. And he wants a radio station in Magdeburg.
Wants to get all religious.
I'm all out of high-power tubes. I don't have any more. I've got enough to keep VOA on the air, hopefully until we can make more tubes. And that's it. No more tubes. For maybe 6, 8, 10 years. So, how are we going to do it? It turns out the first AM radio station, the first